Uh, Hi, my name is Preston.
I'm Carlo.
I'm Moog.
I'm Jason.
Well, for our project, we're all full stack developers. We're all kind of sharing the responsibilities for this project. So there's no kind of clear distinction between back end, front end, or anything. We're all kind of picking up the issues kind of equally and designating the tasks that way. Um, you move to the next slide. So for the actual project problem, for the challenge that we are given, we were tasked with kind of finding an innovative solution needed for environmental protection and sustainability. And to kind of better identify the problem and focus on what we wanted to look at, we were trying to look into the lack of awareness about local environmental risks. So this kind of shows us kind of a gap in knowledge where people are unaware of the risks in their immediate surroundings. And there can be consequences for this because this actually hinders effective action and community engagement for people to kind of address these problems. But this also gives us an opportunity to kind of bridge this information gap and to empower individuals and communities to kind of address these risks. So our focus was to kind of leverage technology and education for practical environmental awareness and to basically directly address the challenge by creating a tool for local risk assessment. You go to the next slide. So for our actual solution, we have Verdant, a user-friendly environmental risk mapping tool. And the key feature here is that it is an interactive website with a navigable US map divided by counties. So that way that people can look all across over the US, their own county, maybe even on the other side of the US. And the main functionality here is that users can explore and access info on local environmental risks. And the data here is also going to be pretty comprehensive. So we're going to provide details on hazards. It can be anything from landslides to floods, anything applicable in the area. We also have at-risk habitats. So this could be endangered, sorted by what's most at risk. Then we can also have pollutants if they're particularly harmful in certain areas. We also have an aspect of personalization where account creation can be used for saving and sharing local risk information. So people can share any information they find important to themselves. And they can also share that information to others to kind of help with community efforts. So we kind of see a few benefits here. So for an environmental impact, we're educating the public on local risks, we're raising awareness. There's also an aspect of engagement where we have sharing capabilities to promote community involvement. Then also for contribution, we're empowering users with knowledge for informed environmental action. Next slide.
Okay, so now for the user stories. The user stories are essentially what we want our users' experience to look like as they use Verdant. And we have kind of broken that down into the elements of the backbone, which are kind of on the left here that we've tagged. Those are the map interactions, discovery of environmental risks, account management, and sharing, as Carlo mentioned in the previous slide. And I'll kind of break some of these user stories down for you. The first one is under the core functionality of map interactions. And from the user's perspective, as an environmentally concerned citizen, I want to click on a specific location on the US map so that I can see environmental risks associated with that area. So part of the conversation around that might be, okay, how does the clicking function work? Will it click and zoom as I go in? What kind of risk will I see when I click immediately? And the acceptance criteria might be that the map actually does zoom into the location or show the location that the user wants to select, and it has a clearly defined environmental risk there. And the discover environmental risk is another part of it. So beyond just the map interaction element where you're clicking on the map, you actually want to have a little bit more interactivity with the actual data that the website processes. So part of the conversation, for example, might be um, what kind of risks can I select? Can I filter the risk? Can I break it down into further smaller categories? Is there an advanced filtering option? And the acceptance criteria would be, yes, there is this element of filtering that I can do and a specific data that I can access through clicking the map and opening these locations. And those would be two examples of the user stories and how we're approaching them and into integrating them into the core functionalities of the website.
Okay, so for the languages and frameworks, we decided that we're going to be using Next.js as a full stack application. And that's simply because there's a lot of libraries and utilities inside of the framework itself that allows us to create these kind of features for our application. And one of like the languages behind this framework is TypeScript, which essentially is a superset of JavaScript, but it also helps us in the developing sense because it ensures that we have our variables and our code type safe and ensure that every time we recompile our code, everything's running as it should. And so for our database, we're using the Postgres language. And what that is that it's a it's a database language for creating databases, and it allows us to use DDL and DMS commands. And then for the styling and like the client side code, we're going to be using HTML and CSS. And those are markup language and style sheets that we'll be using to pretty much manipulate the way information is displayed to the website. And in order to help us create that HTML and CSS, we'll be using Tailwind. And Tailwind is a framework that allows us to pretty much compile CSS code into lines of HTML. And that way allows us to easier debug and see what our components look like on the web page in real time. And so finally, for our last framework or our last utility, we're using a combination of Drizzle plus Neon. And Drizzle is an ORM created by Vercel, and it allows us to pretty much create these SQL commands without having to have all of that inside of a code database, and it allows us to have a much more concise and efficient way of running these commands. And what Neon is that it's a serverless database host where we don't have to have our own server for hosting a database, and we can just rely on Neon for doing that for us.
All right, so for the project layers, our application follows a client server architectural pattern organized into these distinct layers. So for the presentation layer, we have Next.js front end as Jason discussed, and this is the core framework for the user interface. Styling implemented by Tailwind CSS, MUI, and Shad CN. We have the interactive map powered by Google Maps API and user authentication interface for secure access. For the application layer, it handles core functionality. We take those Next.js AP routes and we handle the client server communication, environmental risk processing logic for analyzing formatting data is also handled here. User management services for handling account related operations. And this layer is responsible for data validation and business rules. So for the data layer, this sort of forms the foundation of our data storage and management. The components include Postgres SQL for environmental risk database hazard information storing. We also use data access objects for efficient database interactions and handles data persistence and retrieval operations. Next is the external services layer. This is third-party services that handle our application capabilities, like Clerk Authentication API for secure user authentication, OpenAI maybe for advanced data processing. And we're also going to be using some governmental databases like the U.S. Fish and Wildlife Services, Environmental Protection Agency, and Federal Emergency Management Agency. And lastly, the infrastructure layer. It's the underlying host and deployment platform. The key elements are a Versal cloud hosting platform for the application deployment, database servers for reliable data storage, and this kind of ensures scalability of the whole system. This kind of goes over a little bit more what I just said and how it's all connected. Node.js handles the web server setup. Then control flows to the React-based user interface where users interact with the Google Maps API. Then OpenAI handles text processing and Clerk for authentication again. The database management system combines user data and environmental data. And lastly, the user profile management system creates a flow of information from the user input through data processing back to the interface.
Okay, so this is the risk management plan, just the critical risks that could, be involved or should be considered when we're developing Verdant, and I'll go over them briefly. So I guess the most critical risk for any service that where you're providing logins or anything involving personal information, and ostensibly the users will be providing their addresses or local residence locations too in order to access map locations, and that would be a data breach that could have a catastrophic impact if their data is leaked. It could harm the credibility and the trustworthiness of the website. So for each risk, there's avoidance, mitigation, and contingency plan. And the avoidance would be just to make sure that the login method is safe. That would be, just like we said, the clerk API. Mitigations is just in general recommend strong passwords. And the contingency plan would be, if everything gets jeopardized, you want to suspend the new login so no more information is in trouble. And the second thing is, since we're using a lot of databases and we're hosting these databases, if the databases somehow go down, that could cause a major service issue for the users. And just the only way we can avoid or mitigate this is to be diligent in how we set up these databases, make sure it's done properly and have minimal risks. And the contingency is that I guess if the databases go down, there's still some static information that we've stored somewhere else that if the user opens up the website, they can see something at least, that maybe the whole website's not tanked. And then some smaller risk would be the map glitches and incorrect information. Map glitches would probably result from errors in code and just how we've used or integrated the Google Maps API. And just to mitigate that, we just want to design the code well and, make sure it works on all platforms. So there are styling features for mobile and desktop applications. And the contingency would just be that if there's a glitch, we should at least throw a user error to the user so they'll know something's off. And for incorrect information, basically we just want to make sure that the information in our database is consistently up to date, make sure that's updated with the latest information. And the contingency is if there's incorrect information, there should be some way for the user to report that to the database admin or to the website so we can correct it. And these are notable backlog items in our backlog that wouldn't be in Sprint 1 because they essentially require what is in Sprint 1 to be done, but they are also essential for the core functionality of the website. These would be the map filters in the side panel, displaying risk data given any map click, and fetching and displaying that filtered risk data. So these are all like what we envision to be core functionalities of Verdant. And as you can see, they have a relatively high number of story points assigned to them. So therefore, these are just the notable backlog items that require some setup before they can be completed. Setup that will be done in Sprint 1.
So for the Sprint 1 backlog, our kind of total product backlog items comes to about 120 points. So that would make our velocity 60 points because it's spread across the 2 sprints. And for our estimated capacity, we came to about 64 points. And this is assuming our 4 members willing to contribute about 8 hours per week for the 2 weeks for each sprint. And of course, this isn't all the backlog items for Sprint 1, but just for some notable ones, we have create a user creation feature. This is pretty fundamental when we have later features such as sharing information, creating account info, saving location. Then we also have integrate Google Maps library, which is going to be pretty helpful for correct location information, having an accurate map. The collapsible side panel, while it's pretty small in terms of points, it's going to be pretty helpful later on because we might use that side panel later on for things such as like search filters, maybe even displaying environmental risk information. Then we have the basic pan and zoom functionality. This is kind of on like the user-friendly side of features that we want. So instead of having a static map, you can actually move across, you can zoom in, and this allows people to have much more accurate information and actually click on the locations that they want to. And lastly, obtaining environmental risk data. This is just more connected to finding actually the correct data sets that we want and what we're actually going to end up giving to the user. So that would be kind of like FEMA for environmental hazards or the EPA for endangered habitats.